welcome to a special presentation from WGRS 104.5. We are your hosts, Ian,
Ella,
and Dan.
And we are coming to you today live from Rochester, New York. Our topic today is water issues, both here locally and throughout the world. We have spent the last weeks doing our own investigation into water issues here in Rochester, and we hoped to share our findings here with you today. As a team of students committed to excellent science and excellent teaching, it is our goal that you will learn not just the importance of our water here, but also about the multiple natures of science and how scientific inquiry can help us expand our ways of knowing the world and those of our students. The first step in our journey is figuring out what water we are talking about.
you see here a depiction of the Genesee River Basin, a wide swath of territory stretching from northern Pennsylvania to Lake Ontario that funnels water down towards our site of interest. This water flows over farmland and populated areas, and in reading and researching about the factors that affect water quality, we continue to wonder how these factors impact one of our most important questions: what is in our water? Our team spent a few days exploring the Genesee River in Rochester, where we made observations of the beautiful falls and the many faces of the river, and thought about the ways human activity has impacted our water.
Real and authentic science investigation doesn't always follow a set plan or algorithm that proceeds in an orderly fashion. Indeed, it is messy and constantly in flux, and often starts not with a well-formulated question, but with curiosity, one of the most important natures of science. Our curiosity was piqued when we reached the end of both our exploratory journey and the river's journey, the mouth of the Genesee River and the beaches on Lake Ontario. My teammates and I were immediately fascinated with the features we observed at Ontario Beach in Charlotte, many of which you see in the images here. The long, narrow piers on either side of the river provide for a striking picture, and one can't help but wonder about their impact here at the beach park as they funnel river water out into the lake. You can see in the lower left the stark boundary forms where these rivers meet, and we wonder about the quality of the lake water as compared to the river water. Is the river water as dirty as it looks? What does water quality even mean? How does the mixing of the lake and river water impact water quality around the beach? What is the role of the pier in this process? These and other questions, driven by our curiosity, serve as the starting point for our investigation.
You see in our zoom in a detailed satellite photo of our investigation location, with Ontario Beach on the west side of the river and associated pier. Each pier extends roughly half a mile into the lake from the shore, with the west side pier extending about 340 feet further than the east side. The current flows in a general east-west direction on the lake, causing buildup of sediment on the west side of the pier, evidenced here by the extension of the shoreline further into the lake. We know from past investigations, research, and other readings that this has been implicated in the building up of algae blooms and concentration of bacteria along this side of the pier, leading to beach closures. Monroe County Department of Health has identified 4 major factors as a model for predictive beach closure: prior day bacteria, clarity, rainfall, and algae. These factors ended up being many of the same factors that we became curious about as we carried out our initial observations. Because of the unique nature of each side of the lake, possibly due to the pier, we wondered what this impact was, and more importantly, if there was an impact, what was its magnitude?
So what are the major factors at play? After exploring the areas that we found interesting and worthy of further investigation, our team sat down to determine what factors we thought might be important in helping us develop a more investigable question out of our initial questions. We have already mentioned how water quality is an abstract and ambiguous term. We need to explore other factors that are more tangible, and then the relationships between these factors and our ultimate factors of interest. This led to the development of our model. Our model and its list of factors and relationships has gone through multiple revisions and changes throughout our investigation, and we suspect will continue to do so. The process of revision and reflection is a crucial part of an investigation and one of the key pillars in the natures of science. In the center right stands our abstract factor of water quality. To develop a more explicit standard for what water quality means to us, we began developing a list of factors we believe to be representative of this quality. Our model moves from left to right, beginning with 2 factors we believe to be crucial: weather and the pier, one natural and the other artificial. Between, we've identified two more measurable factors that we believe to be related: the amount of coliform, particularly fecal coliforms, in the water, as well as the turbidity of the water, a measurement of the cloudiness of the water due to the suspended particles. Our investigable questions, which we will discuss and develop later as part of our investigation design, involve the impact of the pier on these two factors in the water, highlighted here in red. Other factors identified as important include the water temperature and river flow. All four of these factors are interrelated. The flow of the river and the sedimentation rate will affect the turbidity. The water temperature will affect the growth of bacteria, and of course, the weather will have an impact on all four. The identification of factors such as these, which are outside the purview of our investigable question, become important later when considering the limitations and confounding factors present in our study. Finally, we connect water quality in the end to two broader impact factors: recreation and leisure in the pier beach area, and human and animal health. These factors have been identified as important in many of the news articles and research done about water quality issues in similar areas, and represent implications that any results about water quality might have on a local or even national and global level. We have chosen to represent these connections with dashed lines, however, because these connections are still unclear. The tenuous nature of these relationships will be important in evaluating the relevance of our conclusions. The development of our initial model led to a preliminary investigable question: what is the magnitude of the impact, if any, of the pier on the amount of bacteria and turbidity in the lake on either side?
So, how did we go about our investigation? Following the development of initial model, we created an investigation plan and determined the ways in which we could collect the data. Our two primary pieces of data we collected were turbidity measurements and coliform bacteria amounts. The turbidity measurements were collected using a Word Science Data Hub, shown in use by Ian in the bottom right. This employs a method of measurement that scatters light rays off of suspended particles, giving values in the unit called nephelometric turbidity units, or NTUs. An example scale published in Agrochemical and Environmental News is shown with values ranging from a less turbid 25 NTUs to an extremely turbid 2000 NTUs. For coliform samples of water were taken on site and plated using 1 milliliter of sample onto easy-scan coliform gels by gently mixing sample and gel and then pouring mixture onto plates, allowing to firm. Gels were then set at room temperature for 48 hours, after which they were counted for total coliform, showing these pictures as both pink and blue-colored colonies, and fecal coliform, which are just blue. Collecting data other than just the variables in question is extremely important for evaluating the accuracy of our findings. Therefore, we collected data on many other variables, which included the air pressure, temperature, and humidity on the data collection days, wind speed and direction, pH, alkalinity, hardness, and temperature of the water. These data were chosen because of their potential effects on our variables of question, as well as their availability of measurement through our tools and opportunities.
So how did we go about this investigation? Following the development of our initial model, we created an investigation plan and determined the ways in which we would collect data. Our first data collection occurred on June 6th. Our investigation design and data can be seen in the image on the right side of the slide. We developed a plan centered around the investigable question: what is the magnitude of the impact of the pier, if any, on the amount of bacteria and turbidity in the lake on either side? In order to test this, we collected samples in the lake on either side of the river, as well as in the river, for comparison. In choosing locations for the samples, we wanted to follow the beach shoreline across the river. However, the difference in distance between the east and the west beaches necessitated another sample taken closer to the beach on the east side. Samples were collected approximately 10 feet into the lake from the beach shores. The weather that day was cold and windy, with air temperatures rising from 17 degrees to 22 degrees Celsius during data collection. A significant amount of waves were observed on both shores. The data displayed on the depiction of the site shows pictures of the cultures grown from each location, as well as total coliform, turbidity, and fecal coliform amounts recorded. Analysis of the total coliform data, also shown in the chart in the lower left, shows that total coliform levels were much lower on the west side of the piers than the east, about 65 mpn per milliliter lower on average. The river samples saw a wide variation, with one site showing less coliform than the east side, while the other showing more. Fecal coliform data showed a similar trend, with no fecal coliform being found on the west side, while 2 colonies each were observed on the east. The river samples had the most amount of fecal coliform on average, with a similar trend in the river sample sites as before. Turbidity data is quite inconclusive. Having small variation around a very high value of 1300 NTU, we suspect other factors are at play here, which we will discuss in our limitations. Overall, a trend was observed showing that the east side of the pier showed higher levels of fecal and total coliforms than the west.
Okay, following the collection of first round of data, our team engaged in an important process of revising our initial model and investigable question. We had learned about the installation of a pipe underneath the west pier to combat a very problem we suspected might occur: algae, bacteria, and sediment building up on the west beach near the pier. Following research into our proposals and the solutions offered for this problem, we decided to modify our question in order to capture the effect of the pipeline as well, which we hypothesized would impact our factors in both the lake and river. For our second round of data collection, we decided to add more sample points both down and upriver of our original horizontal axis. These sites will give us points to compare with the previously chosen sites in order to test our modified question. Data was collected on June 16th, which differed significantly from conditions on our first day. The day was mostly sunny, with air temperatures increasing from 23 to 31 degrees Celsius throughout the day. Windy conditions were observed, but the size and amount of waves were less than June 6th, the first data collection day. Turbidity data, depicted in the chart in the lower left, shows turbidity much greater in the river than either lakeside of the piers, over 200 NTUS on average. Turbidity was slightly lower for samples collected nearest the beach on the west as compared with the east, though the further point downriver was actually higher on the west side by 150 NTUS. Turbidity was found to generally higher on the east river of the river compared to the west, but only by a few tens of NTUS and not consistently. Moving to look at total coliform, similar trends were seen with regard to comparing river with lake samples, with lake samples having far more coliform than most lake samples. In some cases 200 to 300 mpn per milliliter. Unlike the turbidity data though, less total coliform was observed on the east side as opposed to the west. This also goes against the trend observed on the first day of data collection. For the river samples similar to the turbidity data, more total coliform was observed for samples taken in the east side of the river, but no pattern was found comparing upstream to downstream.
Finally, fecal coliform data shows similar trends to those observed in the total coliform. None of the fecal coliform counts observed in the west or east lakesides were above standards set by the Monroe County Department of Public Health, which are 2.35 mpn per mil, though all river samples showed significantly higher values than this standard. From our findings, we can definitively conclude that the river water is more turbid and contains more general and fecal coliforms than the lake water. The magnitude of this difference, however, is open to further investigation. River fecal coliforms exceeded the standards set for beach closure, though beach fecal coliform levels never exceeded this standard on either the west or east side. New York State's water quality standards only state that turbidity cannot significantly exceed normal conditions for a water source, Though other states and sources place a standard anywhere from 50 to a few hundred NTUs, our values for the river were significantly higher than these values. Regarding the difference between the west and east sides of the piers in the lake, our data is inconclusive regarding the relationships here for turbidity and coliform. While data from day 1 seems to suggest the west side has lower incidences of these factors, our results from day 2 suggest the opposite relationship. No clear relationship was seen moving up and down the river, though a general trend of higher values for these factors was seen comparing the east side and west side of the river. Significantly, compared to previous investigations conducted at the same site on the West Beach, total coliform numbers were lower in both of our data collections.
So what can we say and what can't we say? One of the most important goals after completing the data collection phase of an investigation is to determine what your data can tell you. However, it is just as important to recognize the limitations of your investigation and to draw inferences that are within the correct scope. So what are the implications and limitations of our study, and where should we expand from here? In returning to our initial model, we recognize that the pier, while a significant contributor in some manner of our factors of interest, turbidity and coliform amount, represents a difficult subject for investigation due to difficulty in crafting an appropriate investigable question and designing an effective study of plan. Though we have a general idea of how the pier may impact these factors through the manipulation of the current in the lake, we were not able to more directly test the specific mechanism and instead focused on the end product. Perhaps current or some other factor would be a useful addition to help explore the effect of the pier further. In returning to other parts of our model and considering our observations, weather is suspected in playing a larger role than we even initially considered. Perhaps a reframing of our question, investigating the role of weather phenomena, would be of more interest and of use to a predictive model for beach closure and water quality in the area. One major limitation of our study was the amount of samples taken and the frequency of the samples. We did not collect many samples on each side of the pier along the beaches, partially to avoid introducing distance from the pier as yet another variable for study. This, however, gave us, in the end, very few data points to work with, and in analyzing our results, we see a great need for many more days of sample collection. This would increase confidence in the results we do have by reducing the chances of random error, as well as helping to create a better control for the variations due to weather phenomena. Though our study has quite a few limitations, and the conclusions we can draw are limited, our results and experiences give us much more insight into where we might take this investigation in the future in order to be able to draw more meaningful inferences about these issues.
So, why does our investigation matter, and why should we want to continue this investigation further? We still believe the two factors we identified as being connected to water quality in our initial model, human and environmental health, as well as the economic viability of the pier, are quite possibly affected by the broader impacts of the factors in our study. We know that Ontario Beach is frequently closed due to health concerns from fecal coliform presence and other factors. Further, we know that the area in Charlotte was once a local and national attraction that brought business to the community, and that proposals have been made, such as the re-establishment of the ferry to Toronto, to rejuvenate the area. By better understanding these factors that affect water quality, we could possibly hope to draw important conclusions regarding these issues here in Rochester, and the science could hopefully be generalizable to other locations globally that see similar environments around their waterfronts. For example, studies of these issues could be applied to investigate circumstances, such as overgrown algae along the freshwater lakes along the Yangtze River in China, bringing people's concern about water quality and eco-health.
That's it for our show today, folks. We hope you learned a little bit about water issues today, and also the way students, and yes, even teachers, grapple, learn, and grow, conducting science out in the field and in the moment. From all of us here at WGRS 104.5, We would like to extend a special thanks to all of those who helped make this show possible. Good night and good luck.
Bye!
You stay classy, Rochester.